Experiment number 3, Permeability test. Aim to determine the permissibility number of a given specimen for different amount of clay and moisture. Apparatus, permissibility meter, sand rammer, weighing balance, specimen tube, stop clock, 2000 cc measuring jar. Material required: base sand, clay, water. Procedure 1. The experiment is carried out in 2 stages. A. In the stage 1, vary the clay percentage and keep the water percentage constant. B. In the second stage, vary the water percentage and keep the clay percentage constant. 2. Weight quantity of the sand and clay are mixed thoroughly. Third, to this mixture, calculated quantity of water is added and again the mixed thoroughly to get homogeneous mixture. Fourth, the weight of this sand mixture is taken into between 160 to 200 gram or as stated in the lab. Fifth, this sand mixture is transferred to the specimen tube and is rammed thrice in the rammer. Sixth, observe the position of the sand rammer by using tolerance limit provided in the frame of the ram. A. If the top end of the rammer is above the limit, reduce the weight of the sand mixture and prepare the new specimen. B. If the top end of the rammer lies below the limit, increase the weight of the sand mixture and prepare the new specimen. C. If the top end of the rammer lies within the tolerance limit, correct size of the specimen is now obtained. 7th, the specimen as per the standard should be of dimension conforming to the diameter and height of 5.08 cm. 8th, the prepared standard specimen is removed from the specimen tube by using stripper and placed in an appropriate position in the permissibility meter. 9th, adjust the valve to D position and lift the air tank and bring it to the O position. 10. Set the tank level mark to coincide with the edge of the water tank by operating to P or D position. 11th. Screw in the orifice. 12th. 2000 cc of air is held in the bell jar. 13th. Adjust the valve to P position. 14th. The valve is opened and the air in the jar is forced to pass through the sand specimen and the time taken for 2000 cc of air to pass is noted down by using a stopwatch. 15th. When the specimen is impermissible, no air passes through the specimen and the pressure of air below the specimen is equal to the pressure of air coming through the orifice, and this pressure is shown in the manometer. 16th. When the specimen is highly porous, orifice discharge pressure will be equal to the atmospheric pressure or 0 to the manometer. 17th. When a situation arises when the pressure of air entering the specimen is equal to the pressure of air escaping through the specimen, thus a stable reading is obtained on the manometer. 18th. The permissibility number is then calculated by using appropriate formula. Permissibility number can also be read, which is shown by the permissibility meter. 19th, the same procedure is carried out for the part B of the experiment also. The formula used for the permissibility number is Pn is equal to Vh divided by PAT, where V is nothing but volume of air passing through the specimen, which is equal to 2000 cc. H, height of the specimen, equal to 5.08 cm. A is the area of the specimen. T is equal to time taken to pass 2000 cc in the specimen in minute. P is equal to air pressure recorded by a manometer in gram per centimeter square.
So let us conduct permeability test on sand specimen to determine the permeability number. Usually the specimen used will be a sand compressive test specimen of standard size 50.08 millimeter length and 50.08 millimeter diameter, a cylindrical rammed specimen. And permeability is one of the properties of good molding sand with respect to how well gases pass through the sand. So let us see the brief description of parts of the apparatus permeability meter. So now you can see the water tank, the first part, and we have to fill the tank with water up to the level marked inside. And here you can see the inverted bell jar or the simply air tank, and see the markings 0, 1000 centimeter cube and 2000 centimeter cube cc. And here you can see the manometer, water manometer, to measure the pressure of air in centimeter of water or grams per centimeter square. So it is the valve. It has 3 positions: open, O, next P means pressure, and D, discharge. So 3 positions. And here you can see the orifice, 2 numbers. One is 1.5 millimeter diameter and another one 0.5 millimeter diameter. And select one of the orifice, either 0.5 or 1.5 millimeter. And here I will select 1.5 millimeter and fix at the orifice base. And set the other one at the space provided. And here it is the rammed specimen with the sleeve. Let us start the experiment. Now first fill the manometer with water and maintain the water level at 1 centimeter or 2 centimeter, and take whatever the height you set as 0. Note down the initial water height. Now it is reading 2, and take 2 centimeter as 0. Now set the specimen at over the orifice. So along with the cylinder we have to set the specimen. So next, place the air tank into the water tank and set the 0 mark carefully. See, by adjusting valve you can set properly that 0. So 0 of the what air tank should coincide that exact upper height of the water tank. Now move the valve position from open to pressure P and simultaneously start the stopwatch. To note down the time in minutes to pass through 2000 cc of air into the specimen through the orifice, and you can see the air tank slowly coming downwards in the water tank, and once it reaches that 2000 cubic centimeter, so means that much of air, volume of air we have to pass through the sand specimen. Now we are passing that 2000 cc air into the specimen through the orifice. And note down the manometer final reading. So it will be 7 centimeter here, 7 centimeter. Also note down the time reading. It is 2.1 minute. 2.1 minute. Next, move the valve to discharge position D, then take out the specimen from the orifice and move the valve to open position, then lift the air tank.